What is up, YouTube? It's been some time, but let's get on with the next topic, which is comparison of two open table formats, Iceberg and Delta Lake. Before we actually start comparing stuff, let's take a small history lesson how the concept of data lakehouse evolved over time. In the 80s, 90s, warehousing was super popular. People wanted analytics or insights on their data, especially to make decision making, right? So for BI and reports, really made sense to have something like warehouse in place, which was already like an technology evolution over OLTP, which were traditional databases, right? So in 2010s or 11s, the concept of data lake kind of came in, especially with cloud companies having pretty cheap storage as object storage such as S3. So, and also internet was exploding at that time, especially because social media and everyone's like online and whatnot, right? So this data was exploding, storage was cheap, warehouses couldn't handle that, and also there was less flexibility in terms of data can be stored. Like it can be only in rows and columns. It can't be like logs data or like JSON files or like picture images. So data lake kind of facilitated that by having vast amount of storage on cloud. You could easily put everything on cloud without even thinking about it. So there was much less structure to it. Obviously, there's some structure was brought into place using like data masks, also naming conventions, schemas, partitions. Things were brought into place, but essentially this was a lot more flexible. In a way, you can store like anything and maybe think about it later. But essentially, with data lake at that time, there was still need of structure in terms of like tabular data. So what used to happen is data lake and data warehouse were kind of working together. Companies used to keep both. For data lake, everything was kind of put in the first go, and then the warehouses used from data lake to bring in structure, right? So this was the middle stage. But obviously there was limitation. At the end of the day, companies realize, or like people realize, hey, we still need all these capabilities of warehouses within this big data set because of data lake. So something called Lakehouse as a concept emerged, especially from Databricks at that time. From what I remember, they kind of enable structure on top of these. They were pre-existing storage format already. Then kind of came in the open table formats. Eventually, after 2020s, prominent was the Delta Lake. But what happens is the data essentially is stored in pre-existing format. Usually, it's a Parquet, usually partitioned, right? Obviously, within those partitions, there's structure to the data, rows and columns and whatnot. And with the exact data, the metadata is kind of stored with it. Gives you pretty good features for long-term evolution or maintaining of data projects, like big data projects when you're trying to do that, especially on structured data, right? So it gives you reliable asset transactions, atomicity, consistency, isolation, and durability, which are actually quite important features, especially when you think about structured data, and everyone's kind of used to it, especially with like SQL databases, which also comes in right off the box. So it's giving you SQL advantage on top of cheap storage, right? Other features such as advanced data skipping, which we'll get into later, time travel, like having snapshots in place where you can roll back in time, schema enforcement. So compared to SQL database, that doesn't make sense, but if you compare it to data lake or Parquet storages, schema enforcement is pretty big with all these formats, and allows you to have a strict schema in place and help you evolve your structure, right? And keep that evolution being tracked, right? So you can do all of that with all these features, right? It's very easy to have DDLs, data definition language, and also DMLs, data manipulation. It becomes pretty easy, even with SQL syntax, especially when you're using data lake and Spark together. That's what my experience in the past. For other tech, this would be also pretty much similar, I'm assuming. Next, let's look into Iceberg. On a high level, is an open table format, open source, easily available. It allows all transactional features on top of the data lake. It has multi-engine support, which is like one of the key features at the moment, which sets it apart, I would say. So there's kind of a data layer where essentially all the data ingested, maybe you can treat this as a batch ingestion, right? So any data kind of ingested from a batch ingestion, files are being stored in Parquet format. That's like the first step. The next part for an open table format comes like a metadata aspect to it. Starts from usually from a manifest file, which is essentially a metadata JSON file, which contains key information about the data set sweep that is being stored, including schema and whatnot. Parquet also have some level of metadata in terms of like what kind of columns and the types are being stored, but then the manifest file is kind of a next layer to it. So things like, it kind of contains things like file path, partition data, format, count, size, right? Value counts, lower bounds, upper bounds for each column. So it kind of stores all this extra metadata, which easily enable to kind of look through the data easily, query through the data, help perform efficient queries, joins and whatnot. So it really enables efficiency in terms of lookups and whatnot. So that's the way to look at like a manifest file, right? Yeah, so that's how it looks like. There's a bit more information to it, but like that's on a high level, that's how it looks like, JSON file, which with all these extra metadata about the existing data being stored, right? So you treat it as a first batch ingestion. So basically, if an ingestion happens, all these files comes on with a manifest file, right? What happens if new data is kind of coming in? So essentially, that's what happens. A very similar route, a new manifest file is kind of created, which kind of keeps track of all this new data coming in. And in this case, we're assuming like the structure is the same and everything is the same. Sub batch of data being ingested one by one and whatnot, right? So another manifest file gets created for all this new data incoming. To keep track of these two manifest or multiple manifest files, there's another layer on top of it. So it's just not limited to manifest file. There's a manifest list which kind of keeps track of all these different manifest files when new data is getting appended. On a very high level, what Iceberg does is it uses kind of snapshots to point out to these manifest lists, so that it kind of keeps this space, keeps this data structure in space and time, and kind of snaps it out, right? That's one of the metadata which Iceberg uses. Schema changes, which points out to another manifest list being created here, to which points to another manifest file, which points to another data set. So that's how essentially on a high level how Iceberg is keeping track of all these different files. New files are added and being created and being pointed out with all this metadata. So it's as simple as that. Obviously, you get into details. There's a lot more tracking involved in all of these files, especially you want to do asset compliance, you want consistency, you want schema evolution. All of these features are basically being taken care of by all this metadata. And then one more level is to all of this is kind of a database that kind of keeps track of all these different snapshots, which allows you to basically look up all these different tables. For example, there's a table for like taxi rides. This taxi ride table is being pointed to the correct snapshot, which points to a manifest list, which points to an exact data files, right? Let's look at some of its core features. So one key thing is it is an open standard, open table framework. So comes with reliability as a transaction and gives good performance, because all these different snapshots and meta files kind of really track all the upper and lower bounds, which enables you to kind of query it properly, right? So it brings out pretty good performance, and it's an open standard, scalable analytics, and it's like especially quite scalable because it's based on top of object storage and Parquet files. Another key feature which is we kind of discussed earlier as well is multi-engine feature. I think that's the key element where Iceberg kind of outshines. Basically, it allows you to use any engine such as like Spark, Trino, Presto, Athena. Iceberg kind of approached this open format solution as a holistically engine independent. Like you can use either one or you can use multiple of them, right? So it's very easy to do that. Yeah, so we discussed the metadata management is pretty good in terms of Iceberg. So it enables you all the asset transactional features, consistency, durability, right? All of those, and also enables you to have a catalog to kind of point into the right tables at the right time. There's also other features as well. So other pretty good things about Iceberg is how it's mostly you can work your way around in Iceberg using SQL. So it has expressive SQL in place. It supports full schema evolution using snapshots and manifest lists. Another thing which is also a pretty key feature and compared to other competitors is hidden partitioning. It also has like time travel and rollback. All of these features are pretty good for a long term data solution or a platform, then you can kind of maintain it for over a longer period of time. All of these key features kind of enable a robust data storage. So moving on to Delta Lake, this is actually one of the most popular open table format. It came out from Databricks for their own Databricks platform. Really well integrated with Spark. I think that's one of the key features. Came from Databricks, was part of the Databricks ecosystem, and eventually they made it open source for like everyone to use and make it an open source table format, similar to Iceberg. I think kind of more or less they're trying to compete in the same space now. I think let's first look at the architecture. So in a similar fashion, it consists of data files which are in Parquet format, and then there's like metadata on top of it, which actually is in form of transactional log layer. That's what they call it. And so whenever you save files with Delta Lake, there's a storage layer where all the partition Parquet files, multiple Parquet files are pushed in, and then there's another folder where all these different files are logged into. Two different types of files are being logged into is JSON log files, keep track of granular changes per transaction changes. So any transaction that happens, or addition, subtraction, right, it's kind of dealt within this JSON file. And then there's a summarized state of the files which are being pushed into the folder or into the namespace is the Parquet checkpoints, which kind of keeps the summarized state, which is very similar to like manifest files. Maybe there's a bit different in terms of information, but that's the holistic idea. If you look into it, the exact structure, this is how internals of Delta table looks like. These are all the Parquet files, which are like multiple Parquet files based on the partition. And then for each, they for the whole table, they have something called Delta log as discussed, which has different table versions based on like addition, subtraction, and so yeah, Delta Lake kind of allows multiple readers and writers of a given table to work on the table at the same time, which is pretty useful in terms of like when they're streaming, right, and multiple batch processes as well. So it's a single source of truth. It's a central repository to keep track of everything. All user also depends on user, right? Like it also keeps track of what different users or different service accounts being pushing this data or making changes. So this table is being kept track from the Delta log files. So for example, while inserting the data or initially you pushing data into a table, we generate two Parquet files, 1 and 2. This would eventually be added to the transaction log at 000.json, right? That's the current version. That would be the current version, right? So in the subsequent command, we run a delete operation. What it does, it removes those rows from the table, and instead of modifying existing Parquet files, it essentially creates a new Parquet file, and then that Parquet file is being pointed from the 0001 Delta log file, the JSON file. So that's how it kind of keeps track of all the changes happening to the table. So yeah, in terms of internal or the anatomy of Delta tables, first it actually contains data files in terms of Parquet files, which are distributed over partitions and whatnot, right? Then there's transactional log, keeping track of each transaction and add like transactions happening, like to enable asset compliance. So adding of new rows, deletion of new rows is being tracked from the transaction log. Then there's additional metadata, mins, max, and whatnot. Then there's schema structure, and then there's points. Basically, are periodic snapshots of transaction log after every 10 transactions. So there's easier route to access all these different files, and it's much faster and efficient. Some of the Delta Lake features enabling Lakehouse architecture was actually Delta Lake. That's where everything started from. So it supports all the asset compliance, right? So asset transactions, so atomicity, consistency, isolation, and durability. It has something called scalable metadata handling because it has transaction logs, and it also has checkpoints. So that is being enabled by that. It's pretty scalable even for streaming and batch transaction. It has another feature called something called time travel. So you can go back in time be using all these transaction log to look at the same table back in time. Another thing is pretty good schema enforcement via Delta Lake and schema evolution. It's very easy to enforce the schema. Maybe evolution in terms of that, Iceberg is handling things much better, but still there's some version of evolution that can happen where you can at least append columns, right? So that's pretty good. Other things includes CRUD support. So DML, this is where Delta Lake pretty much shines. So you can have Spark SQL jobs with basically DML jobs. All the manipulation is done in SQL. So the support is pretty awesome in there. As I mentioned, they have open sourced it, so that's one of the key features. Like in an open source ecosystem, you're not tied down to a vendor like on only specific Databricks, right? So for example, you start with Databricks and eventually you move out. You can move out, essentially your data can live as a Delta Lake, right? That was the key idea. Good performance optimization using checkpoints and the ease of use, and it's been there for quite a while. At least in my experience, the ease of use is pretty good, and it has pretty good Databricks and Spark support, so it kind of works really well within the Databricks ecosystem. Let's discuss how to choose the right formats. Essentially, we're doing a comparison on each attributes, right, to some of the key attributes, and then kind of allows you to decide, hey, which one to use, right, and whatnot. So yeah, first thing first, ACID compliance. More or less, they are equal on this end, so 1 points for each, I guess. The difference is Iceberg is kind of based on manifest file based ACID implementation. On the other side, Delta table is based on a log based, transaction log based implementation. Schema evolution, we would say Iceberg handles schema evolution a bit better than Delta table. It provides a full schema evolution, including like adding, dropping, renaming, reordering of columns. Delta table, on the other hand, is partial in a way that it only supports mainly adding of new columns. If you want modifying or dropping, it makes sense to kind of do a full rewrite or a manual rewrite. That's actually better to do that. If your use case involves a lot more changes in the schema over time, Iceberg kind of seems a better fit. Partition wise, maybe we can explore this more later on, but maybe there's a slight advantage in partition wise. Iceberg has something called a flexible hidden partition, so it kind of looks like a logical column expression, like as in the example shown here. Whereas in Delta table, it's a fixed partition. You have to, like, it's a Hive style fixed partition. You have to facilitate that direct. So it's basically a directory base. Like for partitioning, Delta table, it's basically implemented at the creation time. So if you want to change that, so you kind of have to do the rewrite. You have to kind of rewrite the whole thing again. Whereas this in Iceberg, the partition can change over time. Technically, that's what the documentation says. Maybe we can explore how it eventually works out, right? Performance-wise, Delta table is more like Spark native, has Spark native optimization. That's what it was originally built for, like based on checkpointing and transaction log, right? So it's basically it's pretty ideal for like using Spark workloads, especially if you think about real time. So DLT, they have something called Delta Live Tables, which is based on internally Spark. So it's pretty good for that. Whereas on Iceberg, it uses snapshots and pruning. So on manifest. So essentially, this is good for Trino, Flink, Snowflake. So essentially, we would say equivalent. Since it has a multi-engine support, but for Delta table, they have a lot more better integration with Spark, right? If your use case is Spark first or Databricks first, also Delta table is kind of trying to approach Iceberg's way of multi-engine support, and it's kind of offering that via Delta Uniform. So there's so via Delta Uniform, Delta table is kind of able to give multi-engine support. Whereas natively, Iceberg kind of supports all these different engine for transformations and whatnot. It's more or less like Spark and Spark and Iceberg are kind of competing in the same space. So they're basically trying to offer most of the features and most of the useful things to their customers, right? Data governance, Iceberg allow to connect to external governance like catalog choice, catalog tools like such as Hive, Glue, etc. Delta table kind of has Unity catalog. Essentially, it's not part of Delta table if you think about it. These are separate entities. But if you're working with Databricks, they kind of have a very tight integration. So Unity catalog and Delta table is like a no-brainer when you're using Databricks. Whereas Iceberg has some flexibility, but you have to kind of pick up a third tool to enable governance on top of your data sets and tables and whatnot. There's something called Delta sharing. Essentially, maybe it's not also a Delta table thing, but since it comes with Databricks, it's good to bring it up, right? So Databricks has something called Delta sharing. They've also open sourced it, if I'm not wrong. So maybe you can combine it with Iceberg, right? But Iceberg has support with Snowflake for sharing data. But the key ideology is Iceberg doesn't want to rely on itself on like sharing and whatnot. It can rely on like other third-party engines such as Snowflake, right? Whereas Delta Table also doesn't have it, but it rely on like Delta sharing, which is separate. But I would say, since I've dealt with Delta sharing, it's a lot more robust platform for sharing data within organization or outside organization. So it's kind of very thought through sharing mechanism via Databricks. That's also, if I'm not wrong, has been open source. So maybe you can just combine with Iceberg later on. The last point is like which format you should go for. Maybe the second last point. So I think I personally feel more or less they are competing in the same space. Obviously, there's slight nuances. You can be nitpicky on which one to choose. But like if you think about Iceberg, if you're looking for a long-term approach, when you don't want a vendor lock-in to any of the platform, and when you want availability of multiple engines, then Iceberg kind of is in direction of that, right? That's the original thought of building that. So it has multiple engine environment, which was discussed, and which make things vendor neutral, right? Other thing is it has partition evolution, which is not part of Databricks, right? This Databricks has relatively fixed partitions, right? Hive style partition, right? It also has snapshot based asset compliance, which is maybe relatively a bit better, right? In that sense. So you can choose, Iceberg in that sense, like, hey, if you want maybe don't want to do a vendor locking, or you want a multiple engine environment, you just don't want to rely on Spark, then eventually you see maybe the evolution is much bigger of your Lakehouse, right? That's pretty good. And then in case of Delta Lake, when you have a tight Databricks ecosystem, if you're already on a Databricks ecosystem, it actually makes sense to use Delta Lake. Obviously, Databricks is being a bit more flexible nowadays, trying to include Iceberg and other open table format. But right off the bat, Delta Lake makes sense, right? Then it has tight Spark integration. Real-time pipelines actually work pretty well with like Spark streaming, and Delta Lake table is actually one of the pretty good example of that, right? So in that sense, choosing Delta Lake if for streaming is good. Delta Lake tables and Spark, I think that's one of the key areas where you can kind of compare both of them. Essentially, what I see personally is more or less the trends are kind of converging. Like both of the formats are trying to compete with each other. So now they have most of the overlapping feature, right? So both of them have like asset support, schema evolution, right? In one way or the other, maybe one is a bit more fixed, right? But essentially both of them provide that support. Delta Lake also, as we discussed, is trying to use uniform to provide multi-engine support. Maybe that's a video on its own later on, right? Delta sharing also by Databricks has been made open source, so maybe it can be picked up by Databricks, the platform you're basing on Databricks on Iceberg storage, right? And Iceberg is also becoming popular because of its like multi-engine support, right? So the trends are kind of converging. I was also looking into one of the talks between both of the founders, discussing both of them are kind of equivalent in a way. There are basically small nuances, maybe where one is better than the other, but the eventual trend is actually it's converging. Each of the players are trying to set themselves apart basically on connectors. So there's a race for connectors. They're trying to build native connectors via the format, so it's very easy to connect to multiple engines, right? What Delta Lake is being doing with uniform, right? Deciding factors would be makes more sense on your use case for you to decide and to see if you have a native connector for built in for that use case. For example, if you're using SAP data, or if you're using other databases, so you have to first see, hey, if there's a relatively native connection for that out of the box, then it makes things easier for you as a data engineer, right? Thanks a lot for watching this video, and if you like the video, definitely hit the like button or like subscribe to the channel if you're new. If you feel there are questions, or if you feel things were not better explained, please reach on the comments. I will try to answer your questions as well in the best capacity I can. So that's all. Thank you for watching. See you in the next one.